Hey everybody, Mrs. Bianchi. We're looking at question number 10, which is a little tricky. And the reason why it's tricky is because W is being subtracted from a number rather than the other way around. So that makes this unique and difficult. We haven't really done too many algebra problems where this is true. So they're asking you to choose the numbers that make the inequality true, select all that apply. So what I'm going to recommend is we're going to try substituting the answer choices in place of W as our strategy on this. And then afterwards, I'm going to show you how we might use algebra. And I'll introduce kind of a way of solving this that maybe you haven't thought of before. So if we go through each choice and we substitute in each suggested number in the place of W to see if it's true, let's start with this value right here, 0. If we do 26 and we ask ourselves, is that minus 0 going to give us a value that's less than 12? If we do 26 minus 0, isn't that going to be 26? Is 26 less than 12? It's not, right? It would be greater than. So that's going to be a no, because it's not a true statement unless we replace it with the green instead of the red value. So that's a no. Now, if we try the next value, which is a 1, and we substitute that in, 26 minus, we're trying, remember 1, we're substituting it, is that less than 12? And if I do 26 and subtract 1 from it, that would be 25. And 25, is that less than 12? That's false. So we're not going to choose that one, right? Because that's not a true statement. It's false. We would need the other symbol, right? We would need the greater than symbol. We could keep going and try the number 2 and see if that's a true statement. So 26 minus 2, is that less than 12? If I subtract 2 from 26, don't I get 24? And if I compare that, is this a true statement? That again is false. False statement, not true. So we're not going to pick that. Now you can continue and go through the remainder of the numbers using this process. But what if we wanted to use algebra? As sixth graders, we don't have a lot of skill on dealing with algebra problems like this. So I'm just going to show you a strategy that you could use. In class, we've talked about if this was represented as a model and you were trying to get rid of, let's say you're going to try to get rid of this and apply the opposite. What's the opposite of subtracting W? And it would be to add W. So I would add W to this side as well. And this is where it gets a little tricky, because what do we really have left? If you're taking a widget away and then you're adding a widget, do we have anything? We don't, right? So I'm going to bring the 26 down, and I'm going to bring the symbol down, and I'm just going to carefully rewrite this. So I have 12, and what am I doing? I'm adding W to that. Now, here's where it gets tricky. I can reverse this. In fact, it might even be a good idea just to remind folks that what I have written here would be the same thing if I wrote it this way, if I said W plus 12. So that's just the idea of using the commutative property. If you change the order of the addends, it doesn't affect the sum. If it presented like this, you're probably more used to this format. And if I present it to you this way, you would say, well, what's the opposite? Adding 12 to a variable. And we would say subtracting 12. And you would know what to do, and that makes more sense. If it's written like this, then you have to kind of rethink this as like a positive 12 and know that the opposite of that is a negative 12. We would still be doing the same thing. And we'd still be getting the same answer. This would still cancel out, just like it does here. And we would bring down the W either way. We'd bring it down here or we would bring it down here. And we would copy the symbol. And we would either way, we would be subtracting the 12 from the 26. So let's go ahead and do that. 6 minus 2 would give us the 4. And 2 minus 1 would give us 1. Now, this is tricky because we're used to having the variable on the other side. How do we read this? We read this as 14 is less than whatever W is. So another way to consider this is that W is the bigger of the two things, right? If we look at the alligator mouth faces the larger meal. So if I'm going to face the alligator mouth this way, what's here in blue and what's here in green really mean the same thing. 14 is less than W, which means W has to be greater than 14. Now this is the format that you're more comfortable with, and if we were to graph that, 14 would not be included in the set because 14 is not greater than 14. That wouldn't, if I replace this with a 14, that would not make this true. But what would make it true, right? What if I think of values that are actually greater than 14? Is 15 greater than that? Is 16 greater than that? So if we were actually going to graph this and shade it, wouldn't we be shading in this direction? So what values are we talking about? Look at the list. What values are shown here that are actually greater than 14? Because those are the ones that you want to pick. Now, if this idea of using algebra is over your head, which it is for many sixth graders because we haven't looked at any algebra problems in class really like this, that's why knowing how to use substitution is going to be a good backup. All right, so again, if you don't understand how to do this, then just keep going with the other numbers and see which ones are true. And anything that's true, because this is an example of a false statement, anything that's a true statement, those are the ones that you want to pick. All right, good luck finishing this up.